Okay, so we are on Journal 7, and today we're going to be looking into naming trig functions on a quadrant. So you're going to see me do that in a little bit. But let's start out with some bell work here. And I picked out some bell work problems that are actually from your homework here. Let me grab my mouse. So we're going to be looking at these homework problems from 14.4. I picked out 1, 5, and 9, and it's asking you to use the appropriate reciprocal identity to find each function's value and rationalize denominators when it's applicable. So what it's saying is like, okay, it tells you the ratio for a given trig function, but this is the reciprocal, right? Secant's the reciprocal of sine. So what is going to be secant's value? Well, in this case, we learned that reciprocal just means that we flip the ratio or the fraction. So secant needs to equal 3 over 2 then. Pretty easy, right? But then when we get to this one here, this one gets a little bit more interesting. Here's tangent's ratio. It's just a 5. Well, that's not a fraction. But I can always make it into a fraction, right? When we put it over 1, right? You can make any whole number into a fraction if you just put it over 1. And so now, cotangent, which is the reciprocal of tangent, has to be 1 over 5 if it's the reciprocal. Okay, now let's try out this one here. This one says sine. It wants to know sine if you know that cosecant, which is the reciprocal, is the square root of 8 over 2. So when we flip this, when we are trying to find sine and we flip this, we get a root or rational number on the bottom. And we can't have that. So we are going to try to rationalize the denominator. So you cannot have roots or rational numbers in the denominator. In order to get rid of them, we are going to multiply the top and the bottom by the same root. So because the root is square root of 8, I'm going to multiply the top and bottom by the square root of 8. This allows me to basically get rid of the root. So the square root of 8 times the square root of 8, well, that would just be the square root of 64. But hang on, the square root of 64, let's think about that. Square root of 64 is just 8. So that's what allows us to get rid of the root. When you multiply two roots that are the same, it cancels out the root, leaving whatever numbers inside. Now, on the top part here, this is 2 square root of 8. And then you would probably try to reduce this, right? In this case, 2 can go into 2 1 time. 2 can go into 8 4 times. So this is really, grab my other pen here. 1 times square root of 8 is just the square root of 8 over 4. Okay, and this answer would be fine. The only thing is, it's not the most simplified answer. Actually, see, the square root of 8 can be simplified further. So what we're going to do is we're going to decompose the square root of 8 into its prime numbers. Because if you remember, square roots has pairs, or this 2 on the outside of the root, right? So it's talking about how many pairs of numbers do we have in here, and specifically prime numbers. So 8 can be decomposed of 2 times 4. 2 can't be decomposed, but 4 can. 4 can be decomposed as 2 and 2. And so you can see here that now I have a pair of 2's, and then I have this leftover 2. So the pair, this pair here, comes out as just a 2. And then you have a leftover 2 here. So that goes back into the square root. And so this is really the more simplified version than this one here. It's because you can take out pairs from a square root. But any pairs that are not, any numbers that are not pairs goes back inside the root. So I can replace this as 2 square root of 2 over 4, and then that allows me to reduce. So 2 can go into 2 1 time, 2 can go into 4 2 times. So this is really the square root of 2 over 2. Whew, that was a bit of work. Now, if you had left your answer right here, I would have taken it. Although this answer is way better. Okay, it's the most simplified. All right, now let's go into today's lesson. Okay, so let's talk about positive trig functions on a coordinate system. So what that means is let's just draw ourselves a coordinate system. We're going to draw a coordinate system. Okay, and so what we're going to do is we're going to label our coordinate system. Remember, this is the first quadrant, second quadrant, third quadrant, and our fourth quadrant. And what I want you to do is to label the coordinate by its positive and negative x and y values. So like in the first quadrant here, they're positive, positive, right? X is positive, y is positive. In the second quadrant, that's when we notice we're in the negative x region. So x is negative here, but y is still positive because we're in the upper region for y. And then in the third quadrant here, we have negative and negative for x and y. And then our last one, we have positive for x, but this time we have negative for y. So we've labeled all our coordinates, and so hopefully you should understand the signs for the different types of quadrants. Now, what I want us to do is just to name the positive, what trig functions are positive depending on the coordinate system. Okay, in order to do that, we first need to understand these trig ratios that's based off of coordinate system. So we went over this last time, and this part you do not, like this, what I'm about to write in blue, you do not need to write in your journals here. But we talked about it. So when we have sine, it's your y over your radius, right? And when we were talking about cosine, it's your x over your radius. And tangent is your y over your x. And then we have the cosecant, right? Which is basically the same as sine, only it's flipped. Secant, which is the reciprocal of cosine, which is going to be r over x, and cotangent, which is x over y. Okay, so here's what I want us to look at, okay? So when you have trig functions, notice how they associate with x, y's, and radius. Now, we learned from the previous journal that the radius will always be a positive number. Now, if you don't believe me, just as a quick spiel, right? The radius, to get the radius, if you have x and y, it's x squared plus y squared, right? And so here's the thing. When you square x, no matter if it's a negative number or a positive number, it's going to get squared, right? Same thing for y. So in this case, both of these will always end up being a positive number. That's why when you take the square root of x squared and y squared, it will always be positive under that root, which makes it safe. Remember, a long time ago in Algebra 2, we talked about not having whenever you have a negative number on the root, you get imaginary numbers, and we can't have that here because radius is a measure of length, so we can't have that. Lengths are always going to be this positive number. All right, so like I said, radius are always positive. So keep that in mind. Although, here's the thing. X is, where's my eraser? There we go. Although x's and y's can change on their values because on the coordinate system, they sometimes can be positive, sometimes they can be negative, right? So what we're going to do is we're only going to play with the trig functions that the basic trig functions. The reciprocal ones are going to be associated to those three. So we really just need to take a look at these three here. So I'm going to first look at sine, cosine, and tangent. And I'm going to look at them from the perspective that they are in the first quadrant, okay? So in the first quadrant, notice how x here is y over the radius. Well, like we said, the radius will always be positive, okay? So I can already think of like whatever number that's going to be, it's always going to be a positive number. Whereas in this case, on the first quadrant, the x is positive and so is the y. So the y here is positive in the first quadrant. Well, when you take a positive number divided by a positive number, you're always going to get a positive number. So in this case, we're going to start naming all the positive trig functions, and sine is one of them, okay? Let's see if we have any more. So cosine, well, it's x over the radius. Radius is always positive, and in this case, x is also positive, right? So that means that it will also be a positive number no matter what the situation is. So in this case, cosine works as well. Then we have tangent, which is our x over y. Well, first quadrant, they're both going to be positive. Positive over positive is still a positive. So tangent work here as well. And I also like to mention, because these three work, right, that means their reciprocal identity will also always be positive. So in this case, all of these trig functions are going to be positive in the first quadrant because x and y's are all positive. So in this case, instead of just writing all the trig functions, let's make it easy on ourselves and just say that all of them qualify, right? Because they do. So in this case, I'm going to write all here. And so the next one here, let's take a look at the second quadrant, because that's when it really gets interesting here, because now it looks like the x here is a negative sign, right? Whereas the y is positive. So let's change the game here. So remember, the radius is always going to be positive. So maybe I'll erase these. I'm not going to erase the radius. So like with this one here, sine here is going to be the y value, which is a positive. Oh, well, in that case, sine here will be a positive. So sine works. And so also that means that cosecant works, right? Since cosecant is a reciprocal. But cosine in this case is a negative. Well, negative divided by a positive is going to be a negative. So, cosine can't work here because in this case, it is going to give a negative value. Tangent, well, that's going to be y, which is a positive, over x, which is a negative. That doesn't work because if you divide that, you'll get a negative side. So tangent's out. So it looks like in this case, the only one that qualifies is sine and cosecant. Okay, so hopefully you're getting the gist of this just a little bit. But what I'm going to do now is just test the ratios again and see what works out. So like I said, I'm going to keep the radius there. All right, let's look at our third quadrant here. So for our third quadrant, again, we're just trying to find out what is positive. For our third quadrant, x is negative, y is negative. So in this case, it'd be sine would be y over the radius. So negative over the positive is going to make this a negative. Oops. Why is that not erasing? There we go. And so that would make it a negative number. So sine is not going to work. Cosine would be x, which is negative, over the radius, which would still be a negative, so cosine doesn't work. Tangent, on the other hand, is y over x, which is a negative over a negative. Two negatives divided by each other is going to make a positive number. So in this case, tangent here is the winner. So tangent works, and also cotangent would work as well, right? Because cotangent is reciprocal. All right, so now we're going to take a look at the next one here. Let me erase these. So for our fourth quadrant, it looks like the y is a negative. So in this case, sine would be a negative over a positive, which would make it a negative. So sine doesn't work here. Cosine would be a positive over a positive, which makes it positive. So this one works. So we could already say that positive cosine, and then its reciprocal is secant, right? And then tangent, well, tangent's going to be the y, which is a negative, over a positive, which makes it a negative. So that case, that doesn't work either. All right, so we've tested all of them, And let me just say that this is a little bit much to remember all of this. So I have a nice acronym to help you remember. So what I like to do is like remember which one is in which quadrant, but only like focusing on the positive trig values, okay? So for the first quadrant, it's all. So I'm going to highlight that A here. The second quadrant is the sign is quadrant, so the reciprocal of sine is positive as well, so that's the cosecant. The third quadrant is tangent, T, and the fourth quadrant is cosine, which is C. So what I like to do is create an acronym for this, and I call it, so this is going to be A, oops, let me write that in a pen, A, S, T, C. So how I remember this is, let me see if I could shrink this down a little bit, is the acronym that goes like this. All students take cash. All stands for, all of the trig functions. Student stands for sign. T, which is going to be takes, stands for tangent. And cash, starting with C, is going to represent cosine. When you say it in the order, you're saying in the order of the quadrant, from the first to the fourth. So my acronym again is all students take cash. And I hope that helps you remember all the positive functions in the coordinate system. Okay, now let's apply this. Okay, so on this one here in the homework problems, it says determine the signs of the trig functions of an angle in standard position with the given measure. So what it wants you to do is first figure out from this angle, what are the trig functions that are positive in that quadrant. So what I would do is probably just draw and figure out where is this angle at. Okay, so in this case, this is 74 degrees. 74 degrees is between 0 to 90 degrees, right? So it's somewhere in the first quadrant. So because we know it's in the first quadrant, well, we can use that acronym that we learned before. I'll do a quick sketch here. So it's all students take cash. And so in this case, the first quadrant says that it's all. So that means that all of them are positive, all the trig functions. So sine, cosine, tangent, and even their reciprocal. So that's what we're going to do here. We're going to name its quadrant and then figure out what trig functions make it positive in that quadrant. So this one here, 218, okay? So this is 0, 90, and then if you're on this side here, that's going to represent 180, and then down here 270, right? So in this case, this quadrant is this angle is down here between 180 and 270, so that's in the third quadrant if we're talking about 218. So third quadrant. Let's take a look at our acronym here. So in the third quadrant, it's T, which represents tangent. So tangent is positive, but remember its reciprocal is also positive. So cotangent is, let's plural, are positive. So, and then this part here, last one, this one's a little bit tricky because it's a negative angle. But we remember that whenever you're going counterclockwise, you're going the positive direction. So if we want a negative angle, we have to go clockwise. So if we go clockwise, well, this is 0, and this would be negative 90. So it has to be somewhere in here. It's negative 15. So we're in the fourth quadrant here. And so the fourth quadrant says that it's C, which represents cosine. So cosine, and secant, because that's the reciprocal, are positive. Okay, so that's it on this one here. All we're doing is figuring out what quadrant is it in and then determining what trig functions are positive in that region. All right, let's do one more slide here for examples. Okay, so in these problems here, you're going to be given a condition of the trig function, and you have to determine what quadrant it's in that satisfies both of these conditions here. So let me just explain a few things on this notation here, because you're going to see it a lot as you go further into mathematics. So you'll see this greater than equal to 0 or less than equal to 0. So anytime you see something being compared to 0 with a less than or equal sign, remember these two things. If it's like x is greater than 0, that's saying that that value is bigger than 0, so that means that it has to be a positive value, right? So if it's bigger than 0, then that turns out to be more positive numbers. Whereas if x is less than 0, that is going to be talking about, well, what are numbers less than 0? Those are going to be your negative numbers, okay? So based on where that inequality is facing, it's either going to be meaning it's a positive value or a negative value. That's just a quick way that in mathematics we can just say that instead of writing a sentence like that. Okay, so what we're going to do next is look at these conditions here. So it says that the quadrant needs to satisfy that sign is greater than 0. So that means that sign needs to be a positive value. Just right here, positive. And then cosecant also needs to be positive. Okay, so looking back at our quadrant or coordinate system that we drew before in the beginning on which one was positive, remember that this one here, the first quadrant is all of them. So all students, which is going to be sine next. Take, which is going to be tangent, and cash, which means cosine. So looking at this here, sine is going to be a positive value when it's in the first, because that's all of them, and the second quadrant. So in this case, I'm going to write that down to keep track, the first and the second quadrant. Now, cosecant is the reciprocal of sine, right? So in this case, it's also going to be the first, because that's all of them, and it's going to be also in the second quadrant. So in this case, first and the second. And so because they are both the first and second quadrant, that means that we can have that in the first and second quadrant, it satisfies these two conditions, okay? Let me go ahead and label these the first, second, third, and fourth. So that way it's easier to just see. Okay, let's take a look at our next problem here. So this one says sine is positive, okay? So we just said a moment ago, this is when sine is positive. It's in the first and second quadrant. But it also says when tangent is positive. So tangent is positive in the first quadrant, because that's where everyone's positive, and then also in the third quadrant. So I'm going to write the first and the third quadrant. But it has to satisfy both of these conditions, and the only quadrant that they both satisfy is going to be in that first quadrant, it looks like. And so in this case, only the first quadrant here will satisfy both of the conditions. Okay, and then the last one here, it says when tangent is less than 0. Well, that means that this here is a negative value, right? And also it says when cosine is less than 0, so it's also a negative value. Well, how do we do it if we only have this rule that's based off of positive trig functions? Well, it's basically what you're going to do is look for the positive and then ignore those quadrant because that's when it's positive. But the other quadrant is when it's negative. So let's think about this here. When tangent is a positive, that is in the first and third quadrant. So we're going to ignore the first and third quadrant. Instead, we are going to be looking at the other quadrants, which would be, so not the first or the third, but the second and the fourth, okay? So in this case, we would have the second and the fourth is when tangent is negative. And then for cosine, when it's negative, we're going to do the same thing here. I wonder if I could erase this. Oh, you know what? I'm actually not going to erase that because I want to see where they overlap. Yeah, I'll do that. So cosine is going to be negative, or let's actually ask ourselves this. When is cosine positive, right? So cosine's positive in the first quadrant and the fourth quadrant. So let me highlight that. Actually, I want to highlight the regions that are negative for cosine. So cosine's negative in the third quadrant and the second quadrant, it looks like. So these two quadrants here. So that means second quadrant and third quadrant. Well, in that case, it looks like the overlap happens when it is in the second quadrant, right? So in the second quadrant, both tangent and cosine are negative. And that's true here, right? Cosine here, the x value is negative, and so that would cause a tangent and cosine to be negative. So it would be this quadrant here. So that would be it. Okay, so that's it for this section here. So the homework that is assigned with this section is chapter 14.4, problems 1 through 44. So check those problems out if you want to do some more practice problems. Other than that, we have one more journal to go before we actually start reviewing for the test. All right, that's it, guys.